Hanno. I'm an IT consultant at Info Support, and the reason this subject speaks to me is because I like to develop software during the day, and when my work is done, I like to play a little guitar and sing a little. So I'm also a musician, so it's obvious that the guitar speaks to me, right? And why Rockstar then speaks to me will become apparent in the talk. Why does it speak to you, Holly, this subject?
Well, I'm Holly Cummins. I work for Red Hat. I help develop Quarkus, and I really enjoy music, and I enjoy listening to music. And you should all be very grateful that this is a two-person talk, and I will not be creating any music. I will be doing a little bit of live coding, and that's the extent of it. So you can thank us now.
I did try to talk her into it, but she wouldn't budge.
No, my family all make fun of me every time I try and sing. But going back to this idea of, leaving music aside for a moment, and let's talk about our careers.
Right.
And Rockstar developers are apparently what the industry wants. When you look for ads, you just see these ads.
Yeah, they're all over the place. We did the work for you here, actually. So if you are pursuing a career in developing Rockstar, here are a few job openings. We're not related to any of the companies that are on display here, but yeah, feel free to use it. Although, when I read these job advertisements, I thought to myself, do these companies even know what they're asking for? I mean, if you're asking for a Rockstar developer, then a Rockstar developer is what you'll get. And what do Rockstars tend to do? Although I think, Holly, you have done the second image once in a while, right?
Oh, totally. Yeah. I mean,
so like
when the code doesn't compile, out it goes.
1/3 Rockstar here then.
Yeah. Yeah. I can do the bad behavior. I just can't do the singing. So I'm almost there.
The basic idea upon which the Rockstar language that we'll introduce is based is I think this tweet by Paul Stovall, who says, to really confuse recruiters, someone should make a programming language called Rockstar. And
once that happens, if you learn Rockstar, you are a Rockstar developer, even if you don't do all of the other things like throwing things out the window.
You would think that that would really decrease the number of Rockstar developer advertisements, but the ones I found were fairly recent, so this needs to be around for a bit longer. Although it's not entirely fiction anymore, because Rockstar is now actually a programming language. And how was it created? Well, a good friend of ours and also a fellow international speaker, Dylan Beatty, was in Australia, and he was sitting in a bar. And of course, what happens when you're sitting in a bar and having a beer or something else? You come up with the most marvelous ideas, right? And this is where he got the creation idea of Rockstar, creating a language that would forever change the meaning of the word Rockstar developer. So let's write a spec for a language like that, right?
There may have been just a little bit of beer involved in the leap from wouldn't it be funny if there was a language called Rockstar to now I'm going to actually make a language called Rockstar.
And also we should correct the image because it was in Australia, so it should be upside down. And there it goes again.
Yeah, we're just going to keep spinning the image.
Right, so after a few beers and a good idea, the actual specification was created for the Rockstar language. And it's actually on GitHub, and you can read about it and see to what rules an implementation should adhere to be an official Rockstar implementation. And as you all know, developers turn coffee into code, and apparently beer into ridiculous language specifications. So that's what happened here. So what is Rockstar actually? Well, it's a computer programming language designed to have programs resemble hair metal power ballads, 80s music, right?
How many of you remember hair metal?
Hair bands.
Yeah, a few of you. For those of you who don't remember, this is what you're missing.
Very high-pitched vocals, screaming guitars, and a lot of wild hairstyles. Yeah, that's exactly it. So thanks to our good friend Dylan, you can now become a certified Rockstar developer. You can even earn a sticker and put it on your resume and, well, apply to all those job advertisements that we just showed you before. So that's the first win for you attending this talk.
Yeah, he's got stickers, and now he's got T-shirts as well. So I think if you search for them, you can find the certified Rockstar developer T-shirt, ideal to wear to your next job interview. So what is Rockstar? I mean, it's a ridiculous programming language, but it's actually in a really good tradition of ridiculous programming languages. It's what's called an esoteric language. And an esoteric language is basically a fancy way of saying it's a language that's designed to be interesting and stupid rather than actually useful or functional or efficient or any of those boring things that, you know, we associate with our languages. And basically, it's a polite way of saying completely useless. So I mentioned that there are some other esoteric languages. There's actually, when you read into it, you can get lost. There's so many of them. One of the most famous esoteric languages is well, I won't say the rest because this may be recorded. And the idea with this language is that all characters other than plus the brackets and the square brackets are ignored. And so if you think your colleague's code is unreadable, this is rather worse. Now, we still have about 5 functional characters here, but we can do better. This is a language, continuing this sort of aquatic theme, this is a language called chicken. And with chicken, the only tokens is the word chicken, and the significance comes from how many chickens you have on each line. You can see chicken is a little bit verbose compared to some of the languages that we're used to. Just a little bit. Although actually, if you think about it, this is actually really similar to binary, right? So you've got chicken or not chicken, and then you combine them to make meaning, sort of. So compared to that, Rockstar is a really sensible, normal, functional language. So let's see what Hello World looks like in Rockstar.
Well, the best part about it is that programs can be sung instead of written, so that's a big plus for me. Christine says, hello world, say Christine. I've just written a program.
It was really cool. The only problem was we didn't actually get Hello World at the end of that. All we got was a song. So can we actually run this? We can. And I mean, there's lots of different ways of running it, but there's a problem. When you look at codewithrockstar.com, should you go there, there are a ton of Rockstar implementations. So there's Satriani, there's Rocky, there's Rockstar Pi, there's one in Rust, there's all sorts of implementations. But if you look, there's a problem with all of these, which is none of them are JVM languages. And I mean, that's a huge gap, right? Like if we can have JRuby, we surely should be able to have Rockstar as a bytecode language. So well, why did we need another language? Because we could, because we thought it would be easy. And fundamentally, as developers, what we do is we reinvent things. That's what we do for fun. So once we decided to do it, the first thing that we had to do, the hardest problem, we had to give it a name. We were a bit stuck. We went to AI. AI did not help as much as we hoped AI was going to help. So the first suggestion was the Brew Fighters. Anybody want to guess what this was from? Yeah, Foo Fighters. We have cream roasters, if you're going way back. There's a lot of these. What it lacks in quality, it makes up for in quantity. We actually cut off the list. I want to draw your attention particularly to Dire Coffee Straits, which is just, well, actually, and the Rolling Stones. So we gave up on AI at that point, and we tried to come up with some of our own. We came up with Rock Starbucks. We came up with,
We didn't want to get sued, so
yeah, we didn't do that one. Came up
yeah.
with Jeff Leopard, bit of an in joke. Yeah, there's like dead silence in this room. And eventually we came up with Bon Jova.
We had to settle for a name, otherwise we wouldn't get to the implementation in the end. So
Yep. I like you all, though, because this is the second time we've done this talk.
Yeah.
And the first time we did it, I said Bon Jova. And again, it was just complete
Dead
silence in the room. And everybody had laughed at ACDCAF, which wasn't even ours. But you all laughed for Bon Jova. So you're our friends. So now that you have the name, the next thing you have to do is the work. So we had to write a JVM language. This seemed like a good idea. It turned out to actually maybe not be quite such a good idea, but we'll come back to that. I saw this tweet recently, because just like you wouldn't steal, a thing, you wouldn't write a compiler. But if you look at the date on that, the date is March 15th, 2024, which is after we'd already written the compiler. So the knowledge came too late for us. So if you want to write a compiler, should you ever wish to write a compiler, don't ever write a compiler, should you ever wish to write a compiler, the first thing that you have to do is you have to write a parser. Actually, you shouldn't even write a parser, though. This is like such a well-solved problem that what you want to do is you want to reuse an existing parser, such as Antler. If you're doing Java, Antler is the logical place to start. I've never used Antler before. It turns out it's really useful for a lot of things, but it's really hard to understand. So there is definitely an investment in Antler, but then once you get there, it pays off. Hands up, by the way, how many of you have used Antler? About 3 hands. How many of you have thought you should use Antler but felt guilty for not using it because it looked a bit too hard? And no hands, okay, just me. So when you say with Antler you don't have to write your parser, that doesn't mean you don't have to do work, though, because instead of writing the parser, what you have to do is you have to write a grammar. And so how Antler works is there's sort of a few parts to it. So if you assume that you start out with a document, which could be a Rockstar program, it could be some business document, whatever it is, what you want to end up at the end is output or actions. And so in this case, we're starting with a Rockstar program. And at the end, what we want to end up with is bytecode. And so what Antler does for us is it gives us this abstract syntax tree in the middle. And in order to get to the abstract syntax tree, what we do is we do lexing, which is breaking the document up into little tokens, and then parsing, which is reassembling those tokens that we just carefully broke up into slightly bigger components called rules. And all of this is happening at parse time. But there's another part of the process that you need, which is a whole bunch of prep work. So you define your Antler grammar, and that defines all of the fragment definitions for your tokens, and your token definitions and your rule definitions. And then your Antler grammar is turned into a whole bunch of Java types and this listener interface for the abstract syntax tree. All of this middle bit is what Antler does. So the generation of the Java types, the generation of the listeners. What you do at the top is defining your grammar. And the other thing that you do is you use your listener interface. Basically, it's a type-safe accessor to give you the results of the parser. And then you can provide a listener implementation. And so when I started out, I had about a quarter of these pieces, and of course nothing worked, and I couldn't figure out why nothing worked, and it was because I needed to do a whole bunch more work. So the fragments I mentioned, those are just basically letters. You can define tokens, which might be a combination of letters, and then you can define rules. And you'll notice that this syntax here, it looks a lot like regex, which is quite good when you get stuck into it, because it means you can do a lot of the things that you would do with regex. And so when thinking about how we put these things together, if the document is a story, then the fragments are like letters. Obviously, they basically are letters. The tokens are like words. And then the rules are like your sentences and your paragraphs. So that's where you get your richer meaning. But it's not so easy to come up with a set of rules that actually does the right thing with the document. So one of the things that I've really found useful doing this is the Antler tools in IDEA. So you know, you're going to need some kind of debugger to try and figure out why nothing works. But assuming you get it basically working, what you can then do is you extend the listener that Antler gives you, and you do useful stuff with it. So each element, each role, you get enter and exits for, and so then you can craft your behavior, you can craft your output by implementing that listener interface. And again, because it's Java, everything is beautiful and type safe, so Antler generates all your types. And then once you've done that, you can then go on to step 2, which is generating your bytecode. Bytecode, again, is one of those things I've always been a little bit intimidated by, so this was a very good learning experience for me. What I now know is I was kind of right to be intimidated by bytecode, because I have occasionally tried to use ASM in the past and found it hard. I tried really hard this time to use ASM and found it hard. So if you look at something like Hello World, and if you were going to do that in ASM, it's so verbose. And in fact, it's even more verbose than that, because I couldn't fit it all on one screen with a decent font size. So it's that. And then the worst bit about ASM to me is the mental model that it has is this visitor interface. So in this code, when you say visit instruction, what you're actually doing is create instructions. And so it's why is it visit if I'm trying to create it? But the good news is I didn't need to worry about ASM. I was able to ignore it because there's another bytecode manipulation library called Gizmo. And this is really it's a layer on top of ASM that just brings it much closer to the mental model that you would probably have as a normal human being who is doing programming. So with that, you can then combine those two pieces and get to something that compiles Rockstar. So we'll show you that, but before we show you that, none of it will make sense unless you know a little bit of Rockstar. So we're going to do a little school of rock. And the first rule of Rockstar, as we mentioned, is if you can't sing it, you can't have it.
Agreed.
So what we're now going to do is a live demo with guitars, because live demos aren't hard enough. So we've got our IDE, we've got our thing, and then we've got a terminal window down here. Sorry, just rearranging my screen. So what we can do is, let's try our code. So
sing it. The answer is sing it.
oh no, fail.
Shout the answer, but don't sing it. Like live demos aren't hard enough already.
Yeah, I could tell you that we tried this. Oh, wrong input. Okay, that is totally the wrong input.
Right.
No.
I'm planning to input device.
Yep, it has helpfully. No, that is the input device. Why is that?
Hello. Let's try again.
Let's try again. It definitely sounds like it's listening to me, doesn't it?
Yeah, is it listening?
It is not listening.
It's also not showing the little microphone icon.
Oh, it's not showing the little microphone icon.
Sing it. Oh, that's just a shame.
That's pathetic. Okay, we have a backup plan.
We do.
Okay. I want you all to, I mean, you could see the intention though, right? Like, and we tried it upstairs in the actual physical venue, and Hanno was singing, and it was working, and it was coming in, but I guess it's the probably the amplification.
Probably.
Okay. So now that we have cheated slightly and typed our program, what we can do... Oh no! Turn off dictation. Okay. That is not the right class path. Okay. Okay. Your turn again, Hanno?
Sorry, because we're singing the class path, right?
Oh, yeah.
Java minus CP Holly /.m2 repository IO. Shall I go on or?
Yeah, that's probably enough.
I'm just singing everything that's thrown my way. But.
Yep. So now, with that rather long class path that you did not listen to all of, we were able to compile it, and so now we can run it, and we get code. So let's get rid
We've
of...
also demonstrated comments.
We have demonstrated comments. So yeah, if it's in parentheses, it's a comment. But one of the first rules of Rockstar really is that if you can't sing it, you can't have it. So comments are there just really, you know, as an aid for if you're really struggling. Okay, let's try output. So
I'm not sure which one this is, but it's just the Hello World one, right?
it is, yeah.
Yeah, I already sang it, but. Christine says, hello world. Say, Christine.
No, that's not right.
That's another one. But this
Close
one would
enough.
also demonstrate output.
Yeah. Yeah.
So can anyone guess what this program will output? Because that's a good one. Some
Yeah.
people read the Rockstar spec in their free time, trying to get to sleep. Well, if I tell you that the words there are significant in the sense that the length denotes the number that comes out of it. So the word low means the number 3, and the period means period, and A means 1. Can someone guess? 3 dots?
Yeah.
Yes, very good. It will output pi.
Yeah. So we've jumped ahead a little bit. So we saw
Right.
output is say or shout or whisper, and then we saw with the Christine says, here you have hello world, but we don't have it in quotes because it's got says in front of it.
Right.
Again, trying to make it stranger. And then now what I accidentally did was the poetic number literals. So again, the idea is that there's so many ways to say the same thing. So we could have it with the tide is low, or this one is actually exactly the same. And so we can confirm that. So if I compile again, and then if I run it, we've got pi. And if I do... Nope. See, I didn't practice my... Nope. I didn't practice my live templates enough because we knew that the singing was gonna work, right?
The dictation was going to
Yeah.
work.
So we'll just do a little bit of that.
Right. It wasn't complicated enough already.
Yeah. And so we can compile that, and then we can run that, and we forgot the output statement. So we can compile that, and we can run that, and we've got the short version of pi because I couldn't be bothered to type it all. So yeah, they all come out to 3.141. So that
was fun.
Yeah.
Looking at this class path. Do we want to continue doing that, or?
Yeah, it's a bit of a painful way to run things. So let's go back to seeing, you know, is there a better way of doing this? Because like for most of our work now, we would never actually compile Java using like a javac command and then try and run it. And in particular, now probably a lot of us wouldn't even expect to go through that cycle of develop, compile, try it out, develop, compile, try it out. Because certainly if you're used to Quarkus, you're probably quite used to live coding. If you're used to JavaScript, you're also used to live coding. So that cycle, when you're used to that, going back to that cycle of doing it and then compiling, it's just a bit annoying. So why Quarkus? Well, there's a couple of reasons. One is that I work on Quarkus. I work for Red Hat, so of course it was going to be Quarkus. But there's some other really good reasons why to do Quarkus as well. Because fundamentally, Quarkus rocks. And what I mean here is, I've got the T-shirt. When we don't just sort of go around to conferences, we do world tours. And when we were at Devoxx 2022, we had a booth. So this is me in there, and was that Devoxx UK as well. Yeah. So
didn't say for a while.
Yeah. So clearly Devoxx is rock and roll. Quarkus is rock and roll. Rockstar is rock and roll. Obviously, it all fits perfectly together. But then when we look at it at a technical level as well, there's a lot of things about Quarkus that rock. So there's the live coding that we want. There's the native compilation, maybe not so useful for Rockstar, but we can see. One of the things that we really do with Devoxx is this idea of developer joy. And what we mean by that is less boilerplate and more action. This one actually is not such a good fit for Rockstar, because I don't know if you've got the impression already with the Rockstar programs, they're not concise. They go on for as long as possible and then perhaps like a little bit longer just for fun. So that one's maybe not such a good fit. Quarkus has a dev UI. Maybe nice. And then, of course, there's this integration with other Java libraries. So if you want to take your Rockstar code and integrate it with Hibernate or with, something else to have transactions in your Rockstar code, then how are you going to do that without the help of something like Quarkus? And there's a marketplace of extensions, so you could, hook into other Quarkus extensions with your Rockstar extension. So we did this.
Yeah, obviously we needed to write a Quarkus extension to really market this to more people, right?
Yeah.
Make sure that we can omit these nasty class paths that we just saw. So that's exactly what we did. As you can see, Jova is now an official Quarkus extension because we're aiming for the moon with this. So it's
my colleagues let me do this, and I was
right.
Really
Oh, I thought okay. I was so proud. We're exactly on the same level as the Kotlin and Scala and our fellow JVM languages here. So that's also what we'll show you a bit later on in the talk, how you can add the Jova extension to your Quarkus project and write your stuff in Rockstar.
But before we do that, let's sort of see how it looks in Quarkus while continuing to also, learn through doing with some more of the Rockstar features.
Right.
So I'm just going to set up a Quarkus app. So if I do Quarkus create app, you could do this with Maven commands as well, but I have the Quarkus CLI, so I just do that. I've got a scaffolded app, so I can bring it up in my IDE. And then I've got, whoa!
Did it crash?
It totally crashed.
I didn't add our extension yet, so that was not the culprit. Great.
Yeah. Okay, so we've got our Quarkus project. The first thing I'm going to do, so it's created me a POM. And I'm just going to add a little bit in here to say that we have, Maven's really oriented around Java. They haven't really caught up with Rockstar yet. So
disappointing.
Yeah. But I'm just going to add in to say I've got another source directory, which is Rockstar. And then I'm going to make that directory source/main/Rockstar. And now that I've done that, I'm going to add my extension. So I can do Quarkus-y add Jova. So I'm, again, adding it into my POM. So yeah, you can see in there, somewhere in there, the POM got added, the dependency got added. And so now I'm going to bring up some live coding. So I can do Quarkus dev. And that will start. And I've got my Quarkus app up. I want to do some tests. So I'm going to start my tests. And these aren't tests that... where is my code?
You need to load the Maven project in the bottom right.
Oh, thank you.
There you go.
Right, here we go. So I've got some test files that just came with the scaffolding. These are for boring REST endpoints, which I obviously don't want any of. So let's get rid of that. Let's make a new test. And I'm going to have a new Java class. And I'm going to call it rock test. And then let's fill that in. There's a whole bunch here. I'm not going to walk through it in detail. Because it's Java code and we're not here for Java code. But you can see basically what it's doing is it's grabbing system out and then doing some comparisons. And at this point, my tests are being run automatically, and they're pretty unhappy because it's looking, if you scroll up, I'm looking for a hello.class, but I don't actually have a hello.class. And I also have 2 package declarations, which is worse. So hopefully now I get the expected error. Eventually down there. Oh my goodness. Okay. I'm just going to quit that, because normally you never need to quit the dev mode. It will just cope with anything, but I think it flooded the terminal. So let's run that. And we should get, yes, a failing test. And so now what I'm going to do is in my... Oh, I was in the wrong directory, wasn't I? That was part of my problems earlier. Yeah. So let's make... my directory. Nope, I have my directory. Why am I... I feel like I'm not in the right directory. Wow. So I've copied the absolute path, and now I'm going to list it. And that is the same path, isn't it?
Did you reload the Maven POM? Oh, I don't think that's it, by the way.
Let's make that error go away. Yes, thank you. That is a good idea. Thank you. Thank you. Okay. So I will do a new file, and I will call it hello.rock. And now what we should be able to do, just as a test, is say, hi, devox. And if I save that over here, we should get the test failing because we've got Hive devox. So
yes.
we are running the code that we think we're running in the place that we think we are. So it's all good. And now we can do some more coding. So conditionals.
Some conditionals.
Shall we try? Let's try the dictation one more. Try the dictation one more time.
Yeah, okay.
No, I don't know why I think it's going to work this
If
time.
you're up for it.
Yeah.
Open was my heart. Listen to your heart. If your heart is open, say love will find a way. If your heart is open, say love is here to stay. I'll say, living on my own.
Yay.
That's the one.
So you can see this is sort of as you'd expect. You've got the ifs and then the elses. And if we look at what got implemented, you can see our test is still failing because I'm being really lazy and I'm just using JUnit basically as a test harness to get my output. And if I scroll up, we've got a null pointer exception.
It needs input. It needs input from standard.
Oh, it needs input from standard out, so this one's not such a good idea. Okay. We won't do that one. We'll move on. Let's move on to loops.
Yes, let's do loops. The walls are high, mighty, while the walls ain't nothing. Knock the walls down, shout the walls. Okay, good enough for now?
I'm a bit disappointed as well because that one also wasn't doing what it did every time when we practiced. Yeah, there we go. So we've got the loop. So you can see the loop is working. So functions.
Power, and power times power, rock bends with 1, 2, 3, 5. Mama wants power, and power times power, rock bends with 0, 1, 2, 3, 4, 5. Wild bands, let charge be poppins, shove mama taking charge. Mama taking charge!
Hey. Although you can see I'm struggling a little bit to find my test output here, so maybe using this as a test harness isn't the exact best idea. So we've got arrays as well, we've got input. But you can see I was not entirely successfully, but had I had more time, I was basically doing TDD with Rockstar, and we can, so it's like Kevlin said this morning, TDD, if you think you can't do TDD in a particular context, you just haven't tried hard enough and you haven't thought about testing.
We can show the output later on, right, in the dashboard?
Yeah,
if you want.
yeah.
Right, so this Quarkus extension that we created, well, I had never written Quarkus extension before, and then I wrote one from scratch, compiling Rockstar to Java bytecode using the compiler that Holly wrote. So it was a very good learning experience for me, and they really can do a lot of cool stuff.
You can see how we split this up as well. So
right.
Hanno did the bit that he knew nothing about, and I did the bit that I knew nothing about to ensure maximum effectiveness.
Yeah, right. And it took up a lot of our time. But extensions make libraries more Quarkus-y. And what do we mean by Quarkus-y? We mean that a lot of things we try to do at build time. So before your application runs, to make sure that at runtime it runs smoothly and no reflection stuff is needed. So that's very, very cool feature of Quarkus. And also you can tap into that when you create an extension. And also it brings you developer joy, of course, if there's a running process and you can see immediately the result of your actions. That really makes us happy. There's unified config, so if you need configuration, you can use the config that's already there. And the dev UI, which we will show you in a minute, you can add all kinds of diagnostic information to the dev UI to, for example, show how many Rockstar programs currently have been found in the source main Rockstar folder, which we will show in a second. Basically boils down to this: if you have to figure stuff out at build time and you have to generate code so the users of your extension or your app don't have to, then you will probably have to manipulate bytecode. And Holly mentioned it already. One of the projects that Quarkus heavily uses is Gizmo, which is this layer on top of ASM that is very good at generating bytecode, but also abstracting the bytecode stuff into typed objects that you can work with directly if you want in your extension. So it's very useful.
The Quarkus developers sort of wrote Gizmo as part of Quarkus because they realized that people integrating with Quarkus would need to do a lot of bytecode manipulation and that they wouldn't want to do it with ASM.
Yeah, exactly. So we also wanted to support live reload. I think we've seen that already for a bit. How we did that. If you don't know how to do something, because I didn't know how to do that, well, then just look at what other people did before you. And this is where we ended up then. A compilation provider interface is provided by Quarkus if you want to write an extension. And actually, the only thing you have to implement is the handled extensions, which in our case was .rock. And then a compile method that gets called every time a .rock file is modified or added to your source directory. So that's basically it. Let's see the dev UI.
Yeah, let's see the dev UI. So this is always useful, and I think it's extra useful here because we saw we were sort of struggling with the terminal just because of the screen real estate and that kind of thing. So in my Quarkus application, you can see I've got a tile for each extension, including Jova. And what I can see with Jova is I can see all of my endpoints. And this is all code that Hanno wrote. So I can click on it and I can implement it, or I can also see the rock score. So
yeah, it exposes a REST endpoint to be able to see the output, and the rock score basically we compare the lyrics to the lyrics of the 100 most popular 80s rock songs and then see how much they compare to them. Yeah, I had some free time on my hands. Yeah. So if you put like the word love in your lyrics, it jumps up by 50 points or something. It's insane. Yeah.
So we've given this talk once before. We had me typing. That turned out to not be very effective. So we had a bright idea, which is that we could sing the code, and that would be so much more effective.
Yeah.
And so we had all sorts of awesome ideas about how to implement it.
And of course, we thought about AI because, well, that's a cool buzzword to include. So we thought about using all these techniques, right?
And we started to completely do it, and then we realized
we were going about this all wrong. For example, Whisper, which is the speech recognition model by OpenAI, didn't really work together with Ollama. Ollama is a way to run LLMs locally. We wanted it to be locally because live demos at a conference, we don't want to rely on the internet. And then we got stuck and then thought about a different approach, which was, well, the one we tried today. Maybe we need
you can see we made such a good decision. We settled on the most resilient approach.
It worked so well outside of this room. But okay.
Imagine how bad it would have been if we'd done something complicated.
All right. So what can we learn from this? Well, actually, we really like to meddle with these things, right? Build something ourselves and then brag about it later on. And this is not really the cool approach, but at least I thought before this talk the most effective, right? And the same thing holds for the Rockstar compiler. I mean, you had a lot of fun writing a Rockstar compiler, but we didn't consider Rocky your Rockstar Java interpreter because not invented here, so we don't trust it, right?
And also I did things in Antler because that seemed like the obvious thing. But if I'd thought about it a little bit more, I would have realized that the reference implementation also had a parser, which uses a parser called PEG, which is a JavaScript parser, but I could have made it work. So I should have done that. And it was it was probably a problem that we did things the hard way, because once we had the Rockstar compiler, we wanted to do really cool things.
Right.
So I was going to do the billion row challenge in Rockstar, and I did actually manage to write it in Rockstar. It didn't quite scale to a billion rows, but it did do the right thing. But the problem is, I could get it to work on the reference implementation. I never actually managed to get it to work on my compiler. So we're not going to show you the billion row challenge in Rockstar. And I kept sort of saying to Hanno, oh, look, yeah, I'm almost there, just one more bug, and then it's going to work. And then, one more bug, and it's going to work. So what this shows, engineers are really terrible at estimation. And pretty much everything that we've done here has been a bit of a catastrophe in terms of estimation. So my family were rather cross at me. Hanno's family were rather cross at
also.
him.
Things had died. Almost the exact same date. It was like they were in sync, right? Or thousands.
Yeah.
Very cool.
And I assume that says basically what my husband said, but in Dutch.
Yeah, but in Dutch. Yeah.
But we are going to show you, we did make some things work beyond Hello World. So let me just show you the final demo. So new file.
Let's scroll to the top.
Yeah, let's see. Yeah.
Daddy wants your dedication and the hug. The goal is not so incredible. Okay, I'm not going to sing the entire thing because we have 2 minutes left.
You can see our Rockstar endpoints. And we've got
It's listed twice.
it's listed twice because we're
Very cool.
quality developers. And you can see, sadly, it's only 50% rock, but if we click on it,
Oh.
in
nice
Rockstar,
and shiny.
sung at Devox.
Yes. Thank you.
I'm just going to jump ahead a little bit because we've got 1 minute left.
Right.
Which is, have you just wasted the last hour of your life? Have we wasted the last several months? I don't think so. You heard this morning, play is valuable. If you want to hear more, you can hear it tomorrow. We will skip all that, but I just want to show you this, because this is a Stack Overflow question that someone asked about a problem that Hanno had solved. And because I'm a bad person, I took Hanno's work and I pasted it into Stack Overflow as my own, and I got the Stack Overflow points.
No attribution whatsoever.
But what it shows is that these things that seem completely pointless actually do teach you things that turns out to be useful for getting points on Stack Overflow at the expense of your mates. So you too should do these useless things.
Yeah.
And with that, we sort of just about got there in time. Thank you very much.
Thank you.